Okay, now for a quick lesson on how to reflect functions across the y-axis. The first thing we'll look at is a rule. This is where if you have a function that contains the point a, b, let's think about what's going to happen here. If we reflect this function across the y-axis, the point a, b is going to go over here, the same distance from the y-axis, but across the other side. And so this was a, this becomes the opposite of a. The new point becomes the opposite of a, but keeps the y-coordinate. Reflecting across the y-axis changes the x-coordinate, but not the y-coordinate. And it changes the sign on the x-coordinate. So the rule for reflecting a function across the y-axis, if g of x is a reflection of f of x across the y-axis, then g of x equals f of negative x, or the opposite of x. So we plug in negative x in the function f of x. Everywhere there's an x, that gives us g of x, which is a reflection across the y-axis. Let's look at an example. If we're asked to find g of x, if g of x is a reflection across the y-axis of this function f of x equals x squared minus 6x plus 5. So we're going to apply the rule. It's a reflection across the y-axis, so we know that it is going to be f of negative x, which means we plug in negative x everywhere there's an x. So this is going to be, instead of x, it's negative x squared minus 6 times, instead of x, it's negative x plus 5. Let's clean it up and simplify that and recall that when we square a negative, it just becomes positive. When we square this negative x, it becomes negative x times negative x, and a negative times a negative is a positive. So negative x squared is just x squared. And negative 6 times negative x makes positive 6x plus 5. So stop the video, graph f of x in y1 and g of x in y2, and verify that this really is a reflection across the y-axis of f of x. Now we'll look at video, or example number 2. Find g of x if g of x is a reflection across the y-axis of the function f of x equals the absolute value of x minus 3 plus 2. Again, we'll use the rule. If you get used to using the rule, you'll learn the rule. G of x equals f of negative x, which means we plug in negative x everywhere there's an x. So we had the absolute value of x minus 3. Instead of instead of x, we're plugging in negative x. And then plus 2 doesn't change, so this function becomes the absolute value of negative x minus 3 plus 2. Some people want to change those signs inside to positive. Let me suggest you don't do that. In this case, it would be okay, but it won't in every case. So once you replace the x with negative x, my suggestion is that you leave it as is. Take the time now, stop the video, graph f of x in your calculator. Remember that in your calculator you can do absolute value by doing math, then go to num, and the first thing on the menu is ABS, which means absolute value. So graph this in y1, g of x in y2, and verify that they are reflections of each other across the y-axis. What if we're given a function in a different form, like a table? If we're given a table of values for a function f of x, where x is negative 2, negative 1, 0, 1, and 2, and the corresponding f of x's are 3, 2, 0, 5, and 7. If we're asked to find g of negative 2, when g of x equals f of negative x, this is the rule for reflection across the y-axis. So we know that this transformation is going to take a point on f of x and reflect it across the y-axis. We want g of negative 2. So if we're looking where x is negative 2, we say that's plug in negative 2 for x. So f of x is negative, g of x is f of negative x. So we're going to do f of negative, take out the negative, take out the x and plug in negative 2. So we get f of negative 2, which is going to be f of positive 2, which is 7. And again, think about this. The point 27 is on the graph. We're looking for what's the y value when x is negative 2 on this function g of x. So if the point 27 is on the graph of f of x, it says f of 2 equals 7. And we reflect it across the y-axis. Where's it going to go? It's going to go to the point negative 2, 7. So g of negative 2 is equal to 7. For example 4, we're given a graph of f of x, and we're asked to find g of 2 if g of x equals f of negative x. This again tells us this is a reflection across the y-axis. We can plug in here. Plug in 2 for x means we plug in 2 for x here. We go to f of negative 2, we could see that that's 1. And if you think of this, if we reflected this function across the y-axis, where would this point negative 2, 1 go? It would go to the point 2, 1, so that g of 2 equals 1. And this is how we're going to do reflections across the y-axis.